Okay, today we're doing a worksheet on linear programming, and which are usually these type of questions are asked in paper 4 and they're related to graphs of linear equations. Okay, and graphical inequalities especially. Okay, let's start with the first question, which says that find the equation of the line L1, L2 and L3, part A. Okay, so let's start with the easiest one. The equation of this line would be, this is 2 at y-axis, so it's going to be y equals to 2. Then we have another line, which is this one. Let's find the equation of this line. For this, I'll have to do y is equals to mx plus c. So I'll do y equals mx plus c, which gives me c is 0 here. C is the y-intercept where the graph cuts the y-axis, so c is going to be 0. What about m? Let's see. So the rise is how many units? The rise is, no, I shouldn't be using this, and I'll use a triangle to find rise over run, which can be read easily, like this one. So the rise is 2 and the run is 1, so m will be rise 2 over run 1, and since it's a rising line, I'll use a positive slope. The slope will be positive and not negative. So the second equation is y equals 2x. We'll do the same for the third one. This was the first equation. Okay, now let's try for line 3. For line 3, the slope, the c is, the y-intercept is 5, where the graph cuts the y-axis, so it's going to be y equals mx plus c. C is 5 and m would be, rise is 5 units and run is 10 units. So 5 over 10, and since it's a falling line, so the slope will be negative. So y equals negative half x plus 5. This is the equation of the third line. Okay. Part B, write down the 3 inequalities that define the shaded region R. So okay, so for the inequalities, let's look at the green line first. The required region is above the line and it was a solid line, so we'll write y greater than equal to 2. For the purple line, the required region is below the line, so we'll write y less than equal to 2x. Since it's a solid line and not dotted line, I'm including the equals to sign underneath the inequality sign. And for the orange line, the required region is again below it, so that means it's going to be less than again. Y is less than equal to minus half x plus 5. Okay. Part C. A gardener buys X bushes and Y trees. The cost of a bush is $30. The cost of a tree is $200. The shaded region R shows the only possible number of bushes and trees the gardener can buy. Find the number of bushes and the number of trees when the total cost is $720. Okay, so let me change this into an expression. So the cost of bushes is 30. So in part C, 30 bushes, so 30x plus 200 trees, 200y equals to 720. Okay. Find the number of bushes and the number of trees when the total cost is 720. Now from the shaded region, choose a value of x and a value of y that will give us the answer 720. For example, if I choose, let's say 3, 3 here, 3 bushes and 3 trees, let's see if I get the answer or not. So if I'm choosing 30 times 3 plus 200 times 3, do I get the answer? 30 times 3 plus 200 times 3, no, I'm getting 690. So I'm close, but not very close. Okay, let's try 4 and 3. Since it's a solid line, we're allowed to take points on the line as well, on the boundary as well. So let's take this one. So 4 bushes and 3 trees. Okay, I'm going to try that now. 4 bushes and 3 trees. Let me enter that here. 4 here and 3 here. 4 and 3. So 30 times 4 plus 200 times 3 is giving me exactly 720. So that means number of bushes is 4 and number of trees is 3. Okay, that's the answer for part C. Okay, part C1 in fact. For part C2, what do we have to do? Find the number of bushes and the number of trees which gives the greatest possible total. Write down the greatest possible total as well. Okay, so now again we have to choose such a value of x and such a value of y so that we get the greatest total. So again for C2, I'll write 30x plus 200y. 30x plus 200y. So if I need the biggest total, that means the value of y should be big because it's being multiplied with 200, and y is the number of trees, right? And trees are on the y-axis. So let's try to choose the biggest value on the y-axis. So let me use a yellow marker. So the biggest value on the y-axis is 4, and corresponding to that the value of the bushes is 2. So I'll choose 2 comma 4. So let me substitute this here. 30 times 2 plus 200 times 4, which gives me 30 times 2 plus 200 times 4 gives me 860. So that's the answer mentioned. So the highest total is 860. And how do we get to this total? When we choose 2 bushes, when we buy 2 bushes and 4 trees. In question number 2, what do we have to do? Okay, so in 1 week Neha spent X hours cooking and Y hours cleaning. So this x-axis represents the number of hours spent cooking, the y-axis represents the number of hours spent cleaning. Okay, the time she spends cleaning is at least equal to the time she spends cooking. This can be written as y is greater than equal to x. Makes sense because it says the time she spends cleaning, which is x, the time she spends cleaning is y, is at least equal to, which means it's either equal to or bigger than the time she spends cooking, which is x. So that's how it's written in the inequality form. She spends no more than 16 hours in total cleaning and cooking. So how do I write this in the form of inequality? She spends no more than 16 hours in total cooking and cleaning. That means the sum of x and the sum of y would be less than equals to 16. So sum of x and y would be less than equal to 16 hours, and she spends at least 4 hours cooking. So at least 4 hours cooking. Cooking is the value of x. So she spends at least 4 hours cooking. That means x is bigger than or equals to 4. At least 4 hours. Okay. Write down 2 more inequality in an x and y to show this information. We've just done that. So this was the answer for part A. Part B, complete the diagram to show 3 inequalities. Shade the unwanted region. So one of the inequalities is already drawn and shaded, which is y is greater than equal to x. Then we have to draw the other 2 inequalities. So I'll draw the green one. X is equals to 4. It's going to be a line over here, and it says to shade the unwanted region. Okay, so it says x is greater than equal to 4. So the required region is towards the right of this line, and I will discard and shade the region towards the left of this line. Okay, then the third line is x plus y is less than equal to 16, which means, let me rearrange this. This is y equals 16 minus x. So it's a falling line. In fact, it's the line y is equals to minus x. This is the line y is equals to minus x, and when you add 16 to it, it means it's translated 16 units up. So it's going to land over here 16, and if this is 16, this will also be 16. So I'll make a line here joining 16 and 16, and notice that since it's a negative slope, that's why it's a falling line. Okay, let me clear this and draw a proper line. So a line joining 16 and 16. Okay, and now it says less than equal to 16. That means the required region is below this line, which means I discard the region above this line. Okay, so complete the diagram to show the three inequalities. Shade the unwanted region. Okay, Neha receives $10 for each hour she spends cooking. So cooking is the value of x, so 10x, and 8 for each hour she spends cleaning, so 8 times y. Work out the largest amount she could receive. So again, the bigger number is being multiplied with x, so we need to choose such a value of x so that it's the biggest possible value of x, so that we get a bigger answer altogether. So where's our shaded region? Our required region is this region. That's the required region. So we need to choose a value of x and a value of y in this region. So I'm trying to maximize the value of x. So that means I can choose this because this is the maximum value of x. Let's see if that would work or not. So I'm going to write 10 times 8 plus 8 times, what's the corresponding value of y here? It's 8. So let's see if that gives us the answer. 10 times 8 plus 8 times 8 gives us 144. Yes, it's the mentioned answer in the marking scheme. So how did I get to this? I used the maximum value of x because x is being multiplied with 10. So if I need a bigger answer, I need to make sure x is the biggest possible. And here's x 8, so that means y is also 8. Okay, in the next question, what do we have to do? A car hire company has X small cars and Y large cars. The company has at least 6 cars in total, which means the sum of these two cars would be at least 6. That means it could be 6, it could be 7, it could be 8, so any value bigger than 6. So we write less than equal to 6. So that's the first inequality that's needed in the question. X plus y is greater than equal to 6. Then the next statement is that the number of large cars is less than or equal to the number of smaller cars. Large car is y, represented by y, is less than or equal to, so less than or equal to number of smaller cars, which is x. Okay, and then the next statement is the largest number of cars is 8. It's the largest number of small cars is 8. So that means the small cars can be 8 or any number less than 8. So it's going to be x less than equal to 8. Okay, so now a small car can carry 4 people and a large car can carry 6 people. On one day, the largest number of people to be carried is 60. Show that this, we have to show this inequality. This is y here. Okay, so one day the largest number of people to be carried is 60. Show this equation. So alright, so a small car can carry 4 people. That means total people in the small car would be 4x, plus a larger car can carry 6 people, so plus 6y. And one day the largest number of people to be carried is 60, so that's going to be less than equal to 60. Okay, now when you simplify this, divide 2 on both sides, we get 2x plus 3y less than equals to 30 that needed to be shown. Okay. By shading the unwanted region on the grid, show and label the region are satisfied by all 4 inequalities. So we need to sketch the 4 inequalities. The first one is x equals 6 minus x. This is the equation of the line. So to plot it, this is actually the line y is equals to minus x translated 6 units up. So it's going to be 6 here and 6 here. So the line y is equals to minus x is simply being translated 6 units up. So this is the purple line. Then the line y is equals to x is simply this line 1, 1, 2, 2, 3, 3 and so on. 1, 1, 2, 2, 3, 3 and 10, 10. So this is the orange line. Then the blue line, x is equals to 8. So that's this line. And then the red line, 2x plus 3y is equals to 30. For this line, I'll have to make a table. 2x plus 3y is less than equal to 30. That means y equals 30 minus 2x divided by 2. Now I'll take a few values of x and corresponding values of y. So x and y, when x is 0, y would be 15. It's 30 minus 3y minus 2x divided by 3. It's actually, sorry, it's 3. So when x is 0, this is 3 here, this is 3. Okay. So when x is 0, y is 10. When x is, if I take x1, I'll get a decimal value, so I'll ignore that. When I take x3, I'll get 30 minus 6, which is 24, 24 divided by 3, which is 8. And then when x is 3, 4, for 4 we'll also get a decimal value. What about 5? 5 will also get a decimal value. 6 will not give a decimal value. So 30 minus 2 times 6 is 18. 18 divided by 3 is 6. 0, 10 is 1 point. 3, 8 is the other point. And 6, 6 is the third point. Join these 3 points with a straight line and you have the third equation. Now let's discard the unwanted region. The first line is greater than equal to 6. That means the region above it is the required region, the region below is the rejected region. Here we have less than equal to x, which means the region below the orange line is the required region, the region above it is the rejected region. Again, for the blue line, it's x is less than equal to 8, which means the region towards its left is the required region, the region towards its right is the rejected region. And for the red line, again it's less than equal to. So region below the red line is accepted region, the region above it is the rejected region. So this region is the required region, everything else is rejected. Okay, done. Part D1. Find the number of small cars and the number of large cars needed to carry exactly 60 people. Okay, so we already have this equation. 4x plus 6y is equals to 60 from part B. So the simplified form is again 2x plus 3y equals 30. Okay, so we've already plotted that line, it's the red line. So we're looking for integer values on the red line, and I've just noticed that I've slightly made a mistake. It should be passing through this red point. So it's going to be a line like this actually. It's going to be a line like this. So please ignore the first red line. It's slightly going to be above this line if you join the 3 dots correctly. Okay, so now I'm looking at the red line and I need integer coordinates on it in the required region. So the required region is this region, and we are on the red line. So the red line in the accepted region is just this line, is this part of the line. Please ignore the lower red line again. Okay, now where are the integer points on this line? It's just this point, 6 comma 6. So it's either 6 comma 6 or this value 7 comma 5.3 is not an acceptable point, since the number of cars cannot be 5.3. Similarly, here we have 8 and 4.5 something, that's not an acceptable point either. So this point 6 comma 6 is the only integer point on this line, on the red line, inside the required region or on the required region. So we choose this point 6 comma 6. So the answer is x is 6 and y is 6, and you can check your answer by doing 2 times 6 plus 3 times 6 equals 30. Okay. In the last part, when the company uses 7 cars, find the largest number of people that can be carried. Okay, so if the company uses 7 cars, that means x plus y equals 70. Which color should I use? I think I've used all of them. Let me use green. Okay, so when the company uses 7 cars, that means x plus y is equals to 7. That means y is equals to 7 minus x. So this is simply the line y is equals to minus x translated 7 units up. So I translate this line 7 units up, and here's the line. Okay, so now what about this line? When the company uses 7 cars, find the largest number of people that can be carried. Okay, so now we need to choose the points on this line that are also inside the shaded region. Okay, so when the company uses 7 cars, find the largest number of people that can be carried. How many people can actually be carried? It's 4 times the number of smaller cars plus 6 times number of larger cars, because it says in the question 4 people can be carried in the small car and 6 people can be carried in the large car. Okay, so what's the biggest value of 4x plus 6y on this line? So we need to choose a bigger value of y so that the bigger value gets multiplied with 6. So the biggest value on this yellow line inside the green region is actually this point, which is 4 comma 3. So if x is 4 and y is 3, I should get the answer. Let's see. Yes, we're getting 34, which is the correct answer. Okay, so in this question, it says that Klaus buys X silver balloons and Y golden balloons for a party. He buys more gold balloon than silver balloons. So gold balloons is represented by X. So we say, sorry, gold balloons is represented by Y. So we say Y is greater than X, because more gold balloons than silver. So Y is greater than X. At least 15 silver balloons. Now silver balloons were again X. So at least 15. X is at least 15. That means it could be bigger than 15 as well, or 15 as well. So X is greater than equal to 15. Okay. Then we have less than 50 gold balloons. So less than 50 gold balloons is represented by Y. So less than 50 gold balloons means Y is less than 50. Can't be equals to, so we're not using the equals to sign in the inequality. Okay, a total of no more than 70 balloons. That means X plus Y cannot be more than 70. So it can be 70 and it can be less. So we'll write less than equal to 70. Okay, and next, what does it say? That write down the 4 inequalities which we've already done in terms of an X and Y to show this information on the grid. Show this information from part A. by drawing 4 straight lines and shading the unwanted region. Alright, so let's quickly draw this line. Y is equals to x is going to be a line passing through 0, 0, 10, 10, 20, 20. So a line like this. Okay, so plotting these lines, y is equals to x is the first line, so it's roughly going to be a line like passing through 0, 0, 10, 10, 20, 20, 30, 30. So it's not going to be a very accurate sketch again. So something like this, a line like this. Then and it's supposed to be a dotted line since it's less than and not less than equals to. So dotted line. Okay. Next, it's x is greater than equal to 15. So this line at 15. Okay. And then it's y is less than 50. So it's going to be this line. And then x plus y is less than 70. I'll just quickly draw this line. It's the line y is equals to minus x translated 70 units up. So it's this line. Okay, now I'll reject the regions that are not wanted. It's x is greater than y, so I'll reject this region. Then it's x greater than equal to 15, so that means I reject this region. Then for the green line, it's y is less than 50, so I reject the region which is greater than 50. And then for the purple line, it's again less than, so I reject the region which is greater than. Okay, and then again the green line was also supposed to be a dotted line because it's just less than and not less than equal to. So this will be a dotted line here. Dotted line means that now in the boundary you are not allowed to take values on the dotted lines, but you're allowed to take the values on the solid lines. Okay, so part C. Okay, silver balloons cost $2, so 2x, and golden balloons cost $3, so plus 3y. Calculate the most Klaus can spend. So Klaus spending needs to stay in this region. So he can choose any values of x in this region and its corresponding value of y. The question says we need to maximize this value. So to maximize this value, we should choose the maximum possible value of y, because y is the one being multiplied with the bigger coefficient 3 and x is being multiplied by 2. So our objective should be to get the biggest possible y in the blue region. So looking in the blue region, the biggest possible value is 49. It can't be 50 because 50 is a dotted line and we can't choose a dotted line. So when y is 49, the maximum possible value of x is 21. So let's use these values. 2 times 21 plus 3 times 49. What do we get? 2 times 21 plus 3 times 14. 2 times 21 plus 3 times 49 gives us 189. Yes, that's the correct answer.